In this example, we're going to be focusing on applications of composite functions. Composite function just being one function that's been substituted into another. So directions. Read each real-world situation and carefully examine each defined variable and function. Area and volume. A spherical weather balloon is being inflated in such a way that the radius is given by r of t is equal to 2t minus 1. Assume that r is in meters and t is in seconds, with t equals 0 corresponding to the time that the inflation begins, meaning that's the initial value. The surface area is given by A of r is equal to 4 pi r squared, and the volume is given by V of r is equal to 4/3 pi r cubed. Compute and simplify A of r of t and V of r of t. So that just means it wants you to take this function here, this radius function, and it wants you to substitute it into the r for the area function. So let's take a look at what the math would look like for that. So A of r of t, right? A of r of t. You would just use the same formula that you see there for area. You have a 4 and you have a pi, and then instead of the r, you would use a parentheses because we are substituting. That's all composite means. Just don't forget that there is a square on the r, so you'd want to put a square on the parentheses. And then inside the parentheses, you're going to take this and put this in for r, so that would mean you would have a 2t minus 1 in here. So this is r. It is, as you can see, 2t minus 1. That r matches there. And now we're going to simplify that algebraically. So we're going to use Gelndas, or the order of operations. And first thing we're going to do is look at the g, the grouping symbol. There is nothing to combine. So we're going to move to the exponent, the square, and that means to write this down twice. You cannot distribute exponents into expressions with addition and subtraction. So we have to write it down twice. That's what square means. It means there are two of them multiplied together. And what we're going to do there is we're going to have to either FOIL this or use the area model. I have really started to like the area model or the box method over the last couple of years. So you write out the first one in a row, and the second thing you're multiplying you write in a column, and then you draw an area model or a box model around those items, and then you can find the answers and place them into the corresponding boxes. So 2 times 2 would be 4, and then we have t times t, which is t squared. And then 2t times negative 1 is negative 2t. And then 2t times negative 1 is negative 2t. And then negative 1 times negative 1 is positive 1. Beautiful thing about the box or area method is that the like terms are always right here on the diagonal. So the items that we have not used are the 4 pi. We're just going to drop those down. So the area model, A of r of t, is going to be equal to 4 pi, and then we're going to add our like terms up. So we'll have, in a parentheses, 4t squared. These two are like terms, so they add up to negative 4t, and then plus 1. And then the last thing we're going to do is we're going to distribute the 4 pi in, because remember, we're going through Gelndas, did the grouping, did the exponents, now we're going to do the multiplication. So if I multiply this times this, I would get 16 pi t squared. If I multiplied 4 pi times negative 4t, I would have negative 16 pi t. And then if I multiply 4 pi times 1, I would get 4 pi. So that would be what it would look like simplified. Some people might want the factored out version, but these are both equivalent. So there is the area model. To do the volume model, V of r of t, be very similar, but we'd be using the volume model that was provided. And those volume models are just from geometry. This area and volume model, they're just from regular old geometry. Would be 4/3, and then pi, and then a parentheses, and then a cube. and then inside of there we're putting r, the same r we had here, so that would be 2t minus 1. And then that would mean we'd have to write it out 3 times. So we would have to actually write this out, 2t minus 1 times 2t minus 1 times another 2t minus 1. But conveniently for us, we already know what 2 of them are. Like, we already know what this is, because that is right here. So we already know that. That would be 4t squared plus 4t, I'm sorry, minus 4t. Let me fix that. So 4t squared minus 4t, and then plus 1. Again, the same thing we had right here. And then I'm just going to box that up, because that is what that equals. I'm just going to put this one down the column, 2t minus 1, and then we'll just go ahead and do the area or box method on that. So it actually goes through pretty quickly if you already know what the square is. And some people memorize a way to square things. You feel free to do that if you want to, but you know, it doesn't hurt to just do that. So 4 times 2 is 8, and then t times t squared is t to the 3rd power. You can see now that it's cubed. 4t squared minus 1, times negative 1 is negative 4t squared. And here we have 2 times negative 4, which is negative 8. And then t times t is t squared. Notice that diagonal has the same variable. Negative 4t times negative 1 is positive 4t. And then we have 1 times 2t again. Notice again that we have the same variable on the diagonal. And then 1 times negative 1 is negative 1. So this volume will be 4/3 times all of that together. So let me give myself a little bit more space here. All right, so V of R of t will be, drop down the 4/3 pi, we never use that, so 4/3 pi, and then times everything in that area model with combined like terms. So 8t cubed, negative 4 and negative 8 are negative 12 t squared. 4 and 2 are 6t, and then we have minus 1. And again, if you want to, you can distribute this through. So that would be 4 times 8 divided by 3, which would be 6 pi t cubed. And then 4/3 times 12 would be negative 16t squared. And then 4/3 times 6 would be 8t. And then, sorry, these should have pi's on them, don't forget it's 4/3 pi, so 16 pi t and 8 pi t. And then 4/3 times negative 1 is negative 4/3 pi. If you wonder how I did that so quickly in my head, what I did here was I did 4 times 8, which is 32, divided by 3. So that actually doesn't work out. I actually made a little boo-boo there, so let me fix it. So that would be 32/3. My brain played a little trick on me there. So let's take a look at, so that would be 4 times 8 is 32/3. That does not reduce, so my brain played a little trick on me there. Let's go through the rest of them. 4/3 times 12 would be 48 divided by 3, so that is 16. And 4 times 6 is 24 divided by 3, so that would be 8 pi, and then 4/3. Sorry about that little mistake there. Okay, so that would be V of R of t. Okay, so now what we're going to do is we are going to use this. That did take quite a while, but these two answers, right? This answer for A of R of t and V of R of t, they're going to be used to work on the rest of the problem. So it now wants me to find A of 2 and V of 3 written in terms of pi. So A of 2, it just wants me to put 2 in this equation. I could have put 2 into here, found the answer, and then plugged it into here. So it's interesting. You can do it both ways. It would actually give you the same value. So that's an interesting thing to think about. So if I were to find a of 2, a would have to go into, notice it doesn't go into t, it has to go into r. So it probably would be easier to find r of 2. Okay, so r of 2 would simply be 2 times 2 minus 1. So r of 2 is just 4 minus 1, or 3, and then plug that into here. So a of 2, remember this is kind of, you're doing word problems, so you have to pay very close attention. The 2, right, has to go into here, and then that would then go into there. So that would be 4 pi, and then times 2 squared. Okay, so that would come out to 4 pi times 4, or 16 pi. Notice it wants it in terms of pi. So you could also have taken the 2 and put it into here as well. And you would have gotten the same answer, but obviously it would have been more complicated in there. Okay, so to find the other one, I'll do that in a different color. To find v of 3, same idea. I'm going to put the 3, it could go into this, okay? Or I could put the 3 into here and then put that into there. So that would be 2 times 3 minus 1. So v of 3 would be 6 minus 1, or 5. And to plug that into my volume equation, v of 5 would be 4/3 pi, and then 5 to the 3rd power. And 5 to the 3rd power is 125. So let's take a look here. Maybe we need to use a calculator for that one. So 4/3 times 5 to the 3rd power is this number, but a lot of calculators have a feature where you can turn it into a fraction, and on the TI you hit math, hit 1 to convert to fraction, enter again, so you just get 500/3. Maybe we could have done that in our head, but I wanted to show you that fraction feature. On Desmos, it's a simple conversion, and on Casio is similar to that. Okay, so remember, it wanted this in terms of pi. So the question is, which one is smaller? And part of that, right, it's an interesting comparison because this one is much bigger than this one, but it also has to do with units. Remember, this would be units squared, okay? So this one would be whatever the units are. In this case, the units are meters. So this one would be meters squared. And this one over here would be meters cubed. So cubic meters. So they're actually not particularly comparable. This number does seem larger than this number. But remember, the comparison, because of the units, is they're really not a comparable unit of measurement. Okay, it's like trying to compare a piece of paper to a box, basically. Like this is a, just a piece of square unit, and this is a cubed unit. So it's like trying to compare the piece of paper you're writing on to a box that comes in the mail. It doesn't have a comparison. So now it says use a of r of t to find the time at which the area of the balloon is 36 pi. And this is such a great question because we have these two answers, right? We had the first answer and then we distributed that answer. So now the question is, right? The question is, which of these would be easier to set equal to 36 pi? And the answer is this one is. Why? It's already factored. So a lot of students will talk about factoring and they'll have some trouble with when they need to use factoring. And factoring is something that is only used when you are dividing. So we're not dividing in this problem, or when you are solving. So it's really important to understand how factoring works. The purpose of factoring is to break something down into smaller pieces, which the only reason you would want to do that is to reduce a fraction for division, or to divide using a polynomial, or to solve. So again, I had these two to pick from. I picked from this one because of the fact that it's already factored with a GCF. So to solve this, all I would do is just divide this GCF on the other side. Notice the like terms, which makes that convenient. And so the pi's actually cancel out, which you would want that to happen or else you would have a mess. And so 36 divided by 4 is, of course, 9. And then I'm left with this function. And the question is, well, what do I do to solve this? And this is going to involve factoring skills from Algebra 1 when you did quadratics. So all quadratics have to be set equal to 0. And once you set the problem equal to 0, you do that by subtracting what was there originally. So get rid of 9 by subtracting it, okay, which will give you -8 as a result. And then ask yourself first if there's a GCF before you start factoring this. A lot of students will be like, I can't factor that because the leading coefficient is too large. And we will be, in Algebra 2, we obviously will be doing problems with lead coefficients, but in this case, they all have a 4 in common, so I can easily factor that out, and the problem becomes very simple, right? Got one step ahead of myself there. It becomes very easy because you factor the 4 out by dividing this by 4 and this by 4 and this by 4, and you end up with that quadratic, which is very easy to factor, because with a minus, you always have a plus minus. So if you don't know that rule about factoring, if this is negative, it's always a positive and a negative, always, no matter what you're doing with quadratics. And then I just need to think of factors of 2, which is only 1 times 2, that will then subtract to -1. So you'd want to put a 1 here and a 2 there, because 1 minus 2 is -1. And then to solve it, remember we're trying to solve this, you would set these two pieces equal to 0. And again, that's just from Algebra 1. So one answer doesn't make sense because you get time equals -1. And the other one, if I set this one equal to 0, I get that at 2 seconds, I'm going to put a unit on it, so at 2 seconds, the area of the balloon is 36 pi using this model. Now keep in mind that model also uses the fact that the radius is this. So it's kind of an interesting, that shows you what the composite nature is. It's a compounding thing. So that's interesting how it actually solved 2 problems at once. Okay, so now use this time from part C to find the volume at the same moment. So now it wants me to take this amount, and that was where the area was, and it wants me to take the area's time here and put it into the volume equation. So again, we could put it into this huge mess, or we could put that back into this that generates the radius, and the radius will generate the volume. Remember, the time generates the radius, and then the radius will generate the volume. So it's kind of like doing part B. So if we find that volume at 2, the equation for the r to find the radius was 2t, so it'll be 2 times 2 and then minus 1. So, oops, that's an r. It's kind of hard to read that. That's let me fix my handwriting there. Okay, so the r equation, right, at the time t, right, so that would be r of 2 would be the radius at 2 seconds would be 4 minus 1 or 3. And now we're going to plug that into the volume equation. So the volume at 3 radius is 4/3 pi 3 cubed. 3 cubed is 27. And 27 divided by 3 is 9. 9 times 3 is 36. Again, let's double check that on the calculator, and then I think I understand why this other question is being asked. So 4/3, leave the pi out, 3 cubed, and that gives us 36. Just making sure. So keep in mind, this one right here would be meters squared, and this one is meters cubed. So the question is, what does this mean? How could this possibly be the same value as this? They're not. This is like a square sheet of paper, and this is like a box. So even though we have the exact same answer, they're not talking about the same thing, which I think is pretty interesting.